Good morning. For those of you that are listening and for those of you that are here with us today, we're talking about the Pythagorean Theorem. We want to look at a right triangle. The Pythagorean Theorem deals with the relationship that exists between the two sides, side A and B, which are called the legs, and side C, which is called the hypotenuse. Okay, so the first thing I want to talk to you about is the three facts about the hypotenuse. It's our longest side, it is the slanted side, and it is also the side that is opposite the right angle. Now, you have studied Pythagorean theorem before, not only in elementary, but also in pre-algebra, probably last year. The Pythagorean theorem tells us that the relationship in every right triangle is a squared plus b squared equals c squared. Or if we were to say that in words, the sum of the square of the sides is equal to the square of the hypotenuse. Okay, so here we go. Our first example. We have our two legs. One leg is equal to 4, one leg is equal to 6, and side C is what we're going to find. So in order to do that, everybody can take your calculators out. We're going to plug our numbers in. C squared equals 6 squared plus 4 squared, or 36 plus 16. Or c squared equals 52. Okay, then we're going to take the square root of 52, and c is approximately 7.2. And we're just going to put a little units right after that. So let's just give ourselves a little reminder. So when dealing with the Pythagorean theorem, let's round to 1 decimal place unless otherwise asked. Did you all hear me? We're going to round to 1 decimal place. Okay. Now we're going to look at a couple of special right triangles. We have the 45-45-90 right triangle and the 30-60-90 right triangle. Because they're angled, it's easier to find the hypotenuse or the legs in these right triangles than in all others. In a 45-45 right triangle, we only need to multiply one leg by radical 2 to get the length of the hypotenuse. Okay. So if they gave us one leg here, okay, which is, this is a 45-45-90 degree angle. So if it's a 45-45-90 angle, triangle, this is one of the legs. I don't care if you want to call him A or B. How did I know that this side right here is not a leg? How did I know that slanted side was not a leg? It's the longest and it's opposite the right angle. So that's the hypotenuse. So hopefully you understand that it doesn't matter if we're going to call the side that measures 7 units leg A or leg B. They're both legs. The two legs are what forms the right angle. So to find this side, so let's just call this side A and say to find B in a 45-90 right triangle, multiply the leg you have by radical 2. And so that's exactly what we did here. We did 7 times radical 2, and when you did that, you should approximately get, let's see if you guys got exactly what they got. 7 times. You should get 9.8999, which is approximately, just leave the test with me. Okay, you need to go with her then, Justin. No, you can go. I'll just send a student with you. It's fine. It's okay. Seven times radical 2 is approximately 9.9. Okay? Now, so that's the formula for a 45-45-90 triangle. Are you with me? In a 30-60-90 right triangle, we can find the length of the leg that's opposite the 30-degree angle by using this formula. Sorry, I went a little too fast. Where did it go? It's somewhere. All right, we shall come back to that because it looks like the formula got chopped off in our notes. So I will go back to my original notes and get back to you on that. All right, what we're going to do at this time is you should be able to look at a triangle, determine which side is missing, a leg or a hypotenuse, and find the missing side. I want to take a little bit of time right now to just go over one other thing with you. That's called the corollary to the Pythagorean theorem. So you're going to have to write this in your notes, okay? You're going to have to add this in, guys. So let's take a look. It's called the corollary to the Pythagorean theorem. It's called the corollary to the Pythagorean theorem. The corollary to the Pythagorean theorem says, if given three sides, can those three sides be the sides of a right triangle? Okay, so let's take a really easy example. We remember what we talked about. We said that in a right triangle, the longest side is always the hypotenuse. So if I gave you these three sides, 3, 4, and 5, and I asked, can these three sides form a right triangle? Okay, so basically you are going to use the Pythagorean theorem, a squared plus b squared equals c squared, and you're going to plug the given numbers in. Does that make sense? Yes? So we're going to plug in 3, 4, and 5. Does it matter if we call 3 side A or side B? What is the only one that we definitely have to put in the right place? C, which would be what?
5.
And we know that side C is equal to 5 because the hypotenuse is always the longest. So here we go. So we're going to go 3 squared plus 4 squared equals 5 squared, or 9 plus 16 equals 25. And if the left side and the right side are equal to each other, then yes, those three sides can form a right triangle. Are you with me? Does anyone have a question? Are you sure? Okay, one more time. This is called the corollary to the Pythagorean theorem. The corollary to the Pythagorean theorem states, if given three sides and asked, can these three sides form or be the three sides of a right triangle? What we do is we take the longest side and make that side C and plug the other two numbers in for side A and B. And we plug it into the Pythagorean theorem, a squared plus b squared equals c squared. If when you plug them in, the left side and the right side are equal to each other, then yes, it can form a right triangle. So let's do another example. Let's have you guys try one. So here are my three sides. 4, 8, and 10. Four, 8, and 10. And go ahead and use our calculators, plug those numbers in. Okay, so 4 squared equals what, guys? 8 squared equals? And 10 squared equals? 16 plus 64 equals? 80. Does not equal 100, and your answer would be no. Does anyone have a question on the Pythagorean theorem? Okay. This concludes our message for today. Thanks for listening with us.